In order to prove trig identities algebraically, one must try to change one side of the identity to match the other using various equation solving techniques. This is an example of a trig identity. In order to solve this, I'm going to pick one side of the equation to try and match the other one. I'm going to try to match this side of the equation to this side of the equation. To begin this process, I began by rewriting this side of the equation since this is the side that I've decided to keep. And on the other side, I'm going to write the opposite trigonometric function using also the opposite symbol. I will then multiply it by the cosecant of theta minus cotangent of theta over secant theta minus tangent theta. Once I multiply these, I will end up with cosecant squared theta minus cotangent squared theta over secant theta plus tangent theta times cosecant theta minus cotangent theta. I'm going to leave the denominator in factored form. And since I know that cosecant squared theta minus cotangent squared theta is another trigonometric identity that equals 1, I can just substitute 1. Now I am essentially multiplying this identity times this, which basically equals 1, in order to get the numerator to be the same as this numerator. When I multiply this times this, I am left with this. And I know that this bottom part of the denominator equals 1. Once I simplify, I am left with this answer. Next, when you are trying to prove a trig identity graphically, you will use a graphing calculator to graph both sides of the trig identity one side at a time. My example is going to be sine of x, cosine of x, tan of x equals 1 minus cosine squared x. I will start by graphing the right side of the equation. This would be better if I have a graphing calculator, but I do not. So this is what 1 minus cosine squared of x looks like. And if I were to graph the left side of this equation, it would also land on the exact same points on this graph. Due to the fact that both sides of this equation match up, this proves that this is a trig identity, and that is always true.